is your Kalpana here. In this video, we are going to see Laplace transforms of elementary functions. Okay, firstly L of k and then L of t power n and L of t from Laplace transforms. So let's start with first one. Prove that L of k equals to k by s if s is greater than 0. Okay, proof. Let s is greater than 0. Now consider L of k. Take L of k. Since we know that from Laplace transform formula, L of f of t, that is Laplace transform of a function f of t is equals to integral from 0 to infinity e power minus st into f of t dt. So this can also be written as capital F of s. Okay. Since you are having constant in the place of f of t, since k is your constant here, right? So you can write it as integral from 0 to infinity e power minus st. Now you have to replace the function in the place of f of t. So you'll write k into dt. Since k is constant, so you can take it outside the integral. Then you'll get k into integral from 0 to infinity e power minus st into dt. Since integral e power ax dx is equals to e power ax by a. If you have minus e power minus ax into dx is equals to e power minus ax by minus a. So this can be written as k into e power minus st divided by minus s. Okay, you can compare with this formula. In the place of s, we have replaced, in the place of a, we have replaced s. So this equals to, since minus s is constant, you can take it out. Then you'll get minus k by s into e power minus st. So you have limits for t, right? When t equals to 0 to infinity. T equals to 0 to infinity. So this is equals to minus k by s into, now apply the upper limit, infinity. E power minus s into infinity minus, now we have to apply the lower limit, which is 0. E power minus s into 0. So this is equals to minus k by s into e power, anything into infinity is infinity, minus e power anything into 0 is 0. Since we know that e power minus infinity is 0 and e power 0 equals to 1, then this becomes minus k by s into 0 minus 1. So this equals to minus into minus plus k into 1 is k divided by s. Okay. So therefore, L of k equals to k by s. Okay. Now coming to second one. Prove that L of t power n equals to n factorial by s power n plus 1. Proof. Let, since they have given when, this is a condition, right? Let n equals to 0, 1, 2, 3 and so on, and s is greater than 0. Now take LHS, that is L of t power n, Laplace transform of t power n. Since we know that Laplace transform of function f of t is equals to integral from 0 to infinity e power minus st into function into dt, which can also be written as capital F of s. Okay, so this is equals to integral from 0 to infinity e power minus st into the function given t power n into dt. So this is equals to, now what we are going to do is, we putting st equals to u. Then if you differentiate on both sides, you'll get s into dt equals to du. Then you'll get dt equals to du by s. Also you're having st equals to u. From this you can write t equals to u by s. Okay. So now we have to change the limits. Since these are the limits for t, now we'll change the limits for u. We'll find the limits for u. So how you'll find? T and u equals to s into t. When t equals to 0, replace t equals to 0, then you'll get s into 0 is equals to 0. When t equals to infinity, u equals to s into infinity. Anything into infinity is equals to infinity. Okay. So now this becomes integral from 0 to infinity. When t equals to 0, u equals to 0. When t equals to infinity, u equals to infinity. E power minus s into, now you have to replace t with u by s into t power n. Again replace t with u by s power n into dt. You're having dt equals to du by s. Okay. So this is equals to integral from 0 to infinity e power s gets cancelled. Then you'll get minus u into u power n by s power n into 1 by s into du. So you can write 1 by s power n into 1 by s as, consider these two, s power n into s can be written as s power n plus 1. So you can write it as 1 by s power n plus 1. So integral from 0 to infinity e power minus u into u power n into 1 by s into 1 by s power n into 1 by s into du. So now you can replace this with 1 by s power n plus 1. So this equals to integral from 0 to infinity e power minus u into u power n into 1 by s power n plus 1 into du. Okay. Since 1 by s power n plus 1 is a constant, so you can take the constant outside the integral, then you'll get 1 by s power n plus 1 into integral from 0 to infinity e power minus u into u power n into du. Okay. Since we know that gamma n plus 1 is equals to integral from 0 to infinity t power x into e power minus t into dx. Okay. Since this is of the form of gamma n plus 1, which is in u, okay, dx du, u power n x t power x, so you'll get x here, gamma x plus 1, and e power minus u you're having e power minus t. Just compare it. Okay, since in the place of x you're having n, so you can replace it with gamma n plus 1 by the definition of gamma function. So this equals to 1 by s power n plus 1 into gamma n plus 1. Okay. Also we know that since gamma n plus 1 is equals to n factorial, this implies L of t power n equals to 1 by s power n plus 1 into n factorial. So this can be written as n factorial by s power n plus 1. So therefore L of t power n equals to n factorial by s power n plus 1. So this completes the proof. Okay. Now coming to the third one. Prove that L of t equals to 1 by s square if s is greater than 0. Proof. Let s is greater than 0. We know that L of t power n equals to n factorial by s power n plus 1. Consider L of t now. Okay, putting n equals to 1. Putting n equals to 1, you'll get L of t equals to 1 factorial by s power 1 plus 1, which is equals to, since 1 factorial equals to 1, so this equals to 1 by s square. Okay, or else you can use the Laplace transform formula to prove this. Now consider L of t. Since L of f of t is equals to integral from 0 to infinity e power minus st into f of t into dt, which is equals to capital F of s. Okay, so this is equals to, we can write it as integral from 0 to infinity e power minus st, since you have t in the place of f of t, so your function is t here, right, into t into dt. To prove this or to solve this integration, we use Eilert rule. Arithmetic comes first, exponential comes next. So this equals to integral from 0 to infinity t into e power minus st into dt. So here t is your f of x and g is your, e power minus t is your g of x. Now we'll use integral by parts formula. Integral f of x into g of x into dx is equals to f of x into integral g of x into dx minus integral of f dash of x into integral g of x dx into dx. Okay. So now we'll apply this formula. So this is equals to f of x into integral g of x, t into integral e power minus st into dt. Next, minus of f dash of x, that is derivative of t with respect to t into integral e power minus st into dt into dt. Okay. Finally, you will apply the limits for t. T equals to 0 to infinity. So this equals to t into integral e power ax into dx minus ax is equals to e power minus ax by minus a. So you'll get t into e power minus st by minus s minus of integral of derivative of t is 1, that is t power dash equals to dt by dt, which is equals to 1, or you can write it as d by dt of t, which is equals to 1. Now integral e power minus st is equals to e power minus st by minus s using this formula into dt. For the limits t equals to 0 to infinity. So this is equals to minus t into e power minus st by s, minus into minus plus integral e power minus st into 1 is e power minus st into dt. For the limits t equals to 0 to infinity. So this equals to minus t into e power minus st by s plus e power minus st by minus s. Then the limits t equals to 0 to infinity. So this equals to minus t into e power minus st by s. So minus into plus is minus into e power st by s into, since you are having s here, right? So you'll write 1 by s. Then you'll get minus into plus minus into 1 by s square into e power minus st. For the limits t equals to 0 to infinity. Now we have to apply the upper limit and the lower limit. Okay. So now we are going to apply the upper limit. For t equals to infinity, minus infinity into e power minus s into infinity divided by s minus e power minus s into infinity divided by s square minus, now we'll apply the lower limit t equals to 0. 0 into minus into 0 into e power minus s into 0 divided by s minus e power minus s into 0 divided by s square. So this is equals to minus infinity into e power S into infinity is an infinity. Since you're having minus, so you'll get minus infinity divided by S minus e power. S into infinity is again infinity and you're having minus sign here divided by S square minus 0 into anything is 0. E power minus 0. Since you know that e power minus infinity equals to 0 and e power 0 equals to 1. So here you'll get minus 0 into e power 0. Again e power 0 is 1. 1 into 0 is again 0. Okay. 0 by S minus again e power minus 0 or e power 0 which is equals to 1. You can write e power 0. Finally you can replace, right? E power 0 by S square. So this is equals to minus infinity into 0 by S minus e power infinity minus infinity is 0 by S square minus 0 by S is 0 minus e power 0 is 1 divided by S square. So finally you'll get 0 into anything is 0. 0 by S is 0. 0 minus 0 by S square is 0. Minus of 0 or minus 0. Minus into minus plus 1 by S square. So this is equals to 1 by S square. So therefore L of t is equals to 1 by S square. S is greater than 0. So in this video we have seen some Laplace transform of elementary functions or Laplace transform of some elementary functions. Hope you will understand. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye bye.